Najashree, and my group members Naveen, Ravi, and Shreyas. Here we discuss the project titled Rule-Based Fuzzy Cognitive Mapping Application in Education. Our project guide, Professor Abdul Karim. Now, in educational organization, students play an important role in the institution. The activities of the students and their performance, it affects the institutional growth. In order to improve the performance of the student and the institutional growth, we have a tool called Rule-Based Fuzzy Cognitive Mapping.
The flow of contents are as follows. Introduction, History of Fuzzy Logic, Literature Review, Fuzzy Logic Inference System, Rule-Based Fuzzy Logic Application in Education, Implementation and Result, and Conclusion. Introduction. Fostering conceptual and cognitive change in learners can be difficult. So we have Fuzzy Cognitive Mapping, a tool for creating meta-knowledge and exploring hidden implications of learners' understanding. Fuzzy logic embeds human knowledge into working algorithms. The algorithms is based on if-then rules and generic decision making. FCM is a tool for formalizing understandings of causal relationships. FCMs allow representation and formalization of soft knowledge domains. It combines the strength of cognitive mapping with fuzzy logic. Performance of the students in an institution, it depends on various factors such as activeness of a student, teaching materials, recency, forums, etc. The main objective is to have the opportunity to revise and improve the education and assessment instruments. History of fuzzy logic. Bertrand Russell, a Polish logician named Jan Lukasiewicz, started working on multivalued logics, that is binary values, logic 0, logic 1. Jade introduced fuzzy sets in the field of fuzzy logic, applying Russell's logic. Hence, he is called the father of modern fuzzy logic. Abraham Mamdani and S. Esselian published a paper on an experiment in linguistic synthesis with a fuzzy logic controller. FCM tool was developed by Costco. Literature review. It's widely accepted within domain of cognitive psychology that students come to school with some form of conceptualization. However, these conceptual are not scientifically accurate. In Cornell universities, researchers developed system of representing conceptual knowledge graphically. In Cornell, there have been several studies conducted on the efficacy of using concept maps as teaching and learning tools. Novak, a person, reports that concept mapping plays an important role in facilitating the change of science teachers. In Cornell, they focused on conceptual changes in students over a 12-year period. The cognitive map graph represents interrelationships among variety of factors. In Cornell University, they use concept maps as teaching and learning tools based on investigation of two categories of potential applications. The first one, they use FCMs in organizational context to promote investigation by participants of the individual. The second one, FCMs have potential applications in intelligent tutoring systems.
Uncertainty or possibility. It is an important tool in generic decision making. It is applicable when model is unknown or impossible to obtain. Here we calculate the student performance from the variety of input variables. Here we need human understanding, especially in soft knowledge domain. Next, fuzzy sets. It is an extension of the crisp set. The membership degree can be taken in the range of 0-1. In extreme cases, if the degree of membership is 0, the element does not belong, and if it is 1, the element belongs to 100% set. Here we take an example. An AC senses the room temperature that is hot to some degree, so that it makes a decision that AC need to be cool. The temperature of some degree. This decision is made by the fuzzy logic. Then crisp versus fuzzy. Crisp logic cannot accurately represent the human understanding, especially in the soft knowledge domain, but fuzzy logic allows us to represent the truth value on the continuous scale from 0 to 1, providing mathematical methods for representing concepts and causalities that are true to some degree. Traditional binary logic requires that a statement must be either true or false. That is, there is no optional between 100% true and 100% false. The problem with the binary system is that it does not allow for accurate representation of the way of human perceives. Here we have an example. If 2 plus 2 is equal to 5, if it is 100% false in the crisp set, but in fuzzy sets it is maybe 40% true and 60% false. So it gives the answer as C. In the membership functions. The membership function is essentially a curve that defines how each point in the input space is mapped to a membership value between 0 and 1. We can give the input variable like very low, low, good, very good. There are different types of memberships. They are the triangular method, trapezoidal, generalized bell-shaped, Gaussian curve, polynomial curve, sigmoid functions. Here we took triangular for the representation of input variables. It's fuzzy set. Fuzzy rules. If x is a, then y is b. The rules in the fuzzy is if then. Here logistic variable is x, y. Linguistic value is a, b. Antecedent x is a and consequent is y is b. If the antecedent is true to some degree of the membership, then the consequent is also true to that some degree. Truth table for and, or, and not operations. The membership functions is mu a union b. For and operation, we are taking minimum value of the membership, and for or maximum value of the membership. For not, constant value membership functions are taken. Fuzzy logic connectivities. For making a rule, the conditions such as if, then, and all with input need the consequences such as and or not. They are named conjunctions and disjunction. The conjunction A union B takes the minimum value of the membership value for and. In disjunction, it takes the maximum value of the membership value for or. Here we can see if there are two antecedent, the conjunction takes minimum value and for and disjunction takes the maximum value.
Fuzzy logic inference system. It defines the non-linear mapping of input data into a scalar output using fuzzy rules. The flow goes from fuzzification to inference mechanism and then to defuzzification. Now we will go through these blocks. Fuzzification. The first step is to measure the values of input variables and to determine a degree of which they belong to each of the appropriate fuzzy sets via membership function, and the output is a fuzzy degree of membership in the qualifying linguistic set. It comprises of process of transforming crisp value into grades of membership for linguistic terms of fuzzy sets. Here we can see two figures. Figure 1, fuzzy sets and crisp reading. In that we see that crisp reading intersects the fuzzy set below low voltage at membership of 0.3. That is, the fuzzy set and the reading can be said to agree at a membership of value 0.3. Figure 2 shows fuzzy set and fuzzy readings. In this, the intersection of fuzzy set medium voltage and a fuzzy voltage reading occurs at a membership of 0.4. Inference mechanism. The IFS maps crisp input into crisp output. It is seen that the fuzzifier, inference engine, rule-based and defuzzifier are the main four components of an FIS. FIS means fuzzy inference system. Linguistic rules that are provided by experts are contained in the rule base. In order to activate the rules that are in the terms of linguistic variables, the fuzzifier has to map input members into corresponding fuzzy membership. The inference engine defines mapping from input fuzzy set into output fuzzy sets. It determines the degree to which the antecedent is satisfied for each rule. The defuzzifier maps output fuzzy sets into crisp members. The mapping involves input-output, membership function, fuzzy logic operators, fuzzy fuzzy if-then rules, ag- aggregation of output sets, defuzzification. Defuzzification converts a fuzzy sets into a crisp output. The defuzzification process examines all the rules outcomes after they have been logically added, and they compute a value that will be finally output of a fuzzy controller. There are many defuzzification techniques as we can see it on the screen, like center of gravity, middle of maxima, maximum criteria, bisector of area, first of maxima, last of maxima, smallest of minimum. Here in our project we are using center of gravity technique. In fuzzy inference method, the fuzzy reasoning splits into two methods, direct method and indirect method. The direct method again splits into three, MAMDANI, Sugino and Tsukamoto method. The MAMDANI fuzzy inference set. In this, the first step is evaluate the antecedent of each rule, then goes to obtain each rule's conclusion, then aggregate conclusion, and that last is defuzzification. In this figure, the first input is at 0.00 and the second input y1 is at 0.1. The both inputs are odd, and the OR output will take the maximum value and give the output as 0.1 at k1. Now the second rule is like x1 is at 0.2 and y1 is at 0.7. Both the inputs will be AND, and the AND will take the minimum output that is at 0.2 and will be shown at k2. The last is a complement. It means x1 will be at 0.5 and it will give the same output at 0.5 at point k3. The next method is Sugino. It is a linear or constant method. If input 1 is at k1 and input 2 is at k2 and input 3 is at k3, then output will be in the form of a k1 plus b k2 plus c k3 plus d. Here for a zero order Sugino model, the output level is as constant and the k1 k2 k3 is equal to 0. Here a, b, c and d are coefficients.
Now I am explaining about implementing the application of fuzzy logic in education, and this implementation is shown using the MATLAB.
Students play important role in the growth of any institute. Students and institution have a tight relationship. Basically, the rating or ranking of any institute fully depend upon the performance of the students. The fostering conceptual and cognitive changes in a learner can be difficult. The student expect the things more and more in their favor or support from the institution and vice versa. The reputed institution focus on the performance of the students and try to do it better so that it could stand in a ranked position as compared to the other institution. The dynamic nature of the FCM makes it useful tool for discovering the hidden relationship between the concepts. Here we are using the three main factors. One is students attendance, next one is teacher effectiveness and facilities. We have discussed the potential usefulness of the fuzzy cognitive mapping in educational organization settings. The development of graphical tools to facilitate the conceptual changes in an important endeavor for educational technologies and facilitates a systematic changes. By combining the capability of fuzzy logic to represent the soft knowledge domain with the dynamic modeling capabilities, the FCM framework has to tremendous potential of contributing to the development of useful cognitive tools. Here, the students' attendance, teaching effectiveness, and facilities. These are the three subjectivities, and then the arrow shows the decision maker that the performance is our output. Then distributed intelligence is showing the structural activity. It will save the mental work and avoid the errors. These are my three inputs. Here on the y-axis 0 to 1, this variable is a membership function. Then very good, good, and medium is my linguistic variables. And then these combining the membership function and linguistic variables called fuzzy sets. This is the third input, linguistic variables are medium and good and very good. Here facilities. Then this is my output of the student's performance. The fuzzy sets of input variables, here giving the ranges of the student attendance. Here it goes like this. This is the second input of the teaching effectiveness. This is my third input, facilities. This is my output of the student performance. These are the ranges. Here in this field of artificial intelligence, there are various ways to represent the knowledge. Perhaps the most common way to represent the human knowledge is to perform it into natural languages. Represents here the if is an antecedent and then is a consequent. These here the two subjectivities, the student attendance is name and then teaching effectiveness. These two subjectivities is connected by the linguistic connectives such as and or and not. But here we are using the and operator. These are my three rules I'm giving for examples. Here I'm using MAMDANI's rule. In this MAMDANI's rule, this is my equation, and then here I'm taking the two attendance. First one is the 0.75 is my first attendance, and then second one is 0.25. These two attendance is my fuzzy inputs. Then this MAMDANI's rule, here we'll check that which is the minimum. So here you can see 0.25 is the very minimum. So in this 0.25 it will go and cut the attendance performance. Then this is the one result. Here I am taking so many rules. Here this is one rule, this is second rule, this is third rule. In this first rule, here I am taking the 0.55 and here one more is 0.4 is my two inputs. Here it will cut the one part and then it will take this and then in the output of the performance, student performance, and it will cut. So this goes like this. After we are getting this output. After that we are finding the center of the method. This is called defuzzification. In this, we are using the center of gravity. After using this formula, we will get one center. It falls on the x-axis, which is that will be in the percentage words. So we got the 50.87 is my one out performance of the students. This is called result of the defuzzification. Now we are going to the implementation part. This is a MATLAB software. We are using the 2012 version for our project. Here you can see the white background. This is called command window. Here we are giving the fuzzy command on the command window. When I giving the command window, so the FIS editor will pop up. Now here the first procedure is the first rule have to coded and written in the M file and saved with the FSM extension. So here when I click in this picture, I'll get the one window is contained with the membership function plot and the input variables. Here this box in the params, I can change the value, I can give the ranges. Here is the name. These are all the method. This is I'm using triangular method for my project convenience. This is my output of the student performance. So totally I have three inputs. So here I'm already done that project. So I'm showing here. I'm importing from the file. Here, then the FIS editor will open by typing the fuzzy command window. They require the FIS files extension. After loading this FIS file, controller is reading to be operated. Then the first of the rule is the FIS editor membership functions of any input and output variables can be seen clicking of any input or output. Clicking on any input or output. Here is the membership function of this input. Student, here is the student and then teaching effectiveness and facilities, and this is the performance of the students. Similarly, the membership function of the output also be seen in here. In this FIS editor, the rules window by clicking on the view rule and surface can be seen. This is the rule window. This is the rule window and the surface view of the whole FIS editor. Now I'm here. Now I want the simulation part. So I'm exporting this file to workplace. This is my file name. When I clicking the simulink, go to the main window. Here is MATLAB main window. Here is some simulink. When I clicking the simulink, so one page will pop up. Here I can give the new window also. Here I'm already generated one window. I'm opening with this file. This is the simulation part. These are the three inputs. These are the inputs here, which is student attendance, teaching effectiveness, and facilities. This is marks, which is used for the combining all the input into the single output. This is some using fuzzy controller using MAMDANI's rule and using student performance. By clicking this value on the box, I'll get one new box will pop up. Here I can give the new value for student attendance. Here if I'm giving the 80 of the student attendance, then here is the teaching effectiveness is 90, then facility is around 80. After giving this, when I start simulation, we'll get the output. This is 87.7, 4.7 is my student performance. And then, bye.